We will continue discussing significant figures, and in this video we will talk first about rounding and then the rules that we're going to use when we do calculations with measurements and how we can determine the significant figures of our final answer. And then we're going to introduce the concept of conversion factors at the very end. First of all, rounding, we all should be familiar with this, but just as a review, we need to round at certain answers. So our final answers should be rounded. Anytime you have to submit an answer in your homework set, but even during laboratory, you're going to pay close attention to this. You're going to be rounding. You cannot report your answer in 15 digits as your calculator gives you the answer. We're going to first determine how to calculate the significant figures of our answer and then how to round. When we round and we determine the correct number of the digits, the significant figures that we need to keep, we can draw a line after the last digit that we want to keep. So in this case, in the number 102.731, we have determined that our answer should have 5 significant digits. So 1, 2, 3, 4, 5. And we draw a line in between the 5th and the 6th figures, and we intend to get rid of that 1 here at the very end. Now, when we draw the line here, we have to determine whether we are rounding up or down. And that will be dependent on what this number that is being cut off is going to be. If the number that is being cut off is less than 5, we just drop everything, and I could have 10 more digits after this one. But this one is important because it's right next to that line that I drew. If it is less than 5, I can drop everything else behind this line, and the number in front of it will stay the same. We should know by now that this is known as rounding down. Now, if the digit is 5 or greater, we increase the digit that we're going to keep, so the digit right to the left of that line, by 1. And this is rounding up. Once again, this is nothing new. We're familiar or should be familiar with this type of rounding if you've done any science or math in school at all. Now, a word of caution, when we are doing calculations with multiple steps, if we round after every step, then we tend to get a large rounding error at the end. Therefore, we should try to hold off the rounding till the end of the final step. So if I have a question or several questions, 1, 2, 3, and they're all related, so they're calculations that are tied to each other. So 2 depends from 1 and 3 depends from 2. If I cut off right at 1 and then I use that number and round off again at 2 and then round off at 3, my final answer at 3 might have a rounding error because I've rounded so much. In these types of calculations, I would suggest that you report several extra digits on answer 1 and 2, but make little notes on how many significant digits your answer should have at 1 and your answer should have at part 2. And that way, when you go to figure out the significant figures in part 3, when you do round, you round to the correct significant figure. Now, we are going to discuss the different operations that we can do and how can we determine the significant figures. There are 2 rules that we're going to follow. The adding and subtracting, or dividing and multiplying. And they are different rules. So once you get the rules, though, you should be able to follow just very easily. You have to practice a few of these to get the hang of the rule, because I have seen students that think they've got it down, but then when they come to test time or whatever, they tend to get them confused. So pay attention closely to what the rules are. As long as you follow the rules, you should be fine. When we add or subtract, the rule is the same when we add or subtract. The answer cannot have any more digits after the decimal point than the number that has the smallest number of digits after the decimal. What does that mean? It sounds a bit confusing, but let's look at this example over here. So I'm adding 102.50 to 0.231. Since I'm adding or subtracting, but in this case I'm adding, the numbers in front of the decimal point for all the addends do not really matter. I focus on what comes after the decimal point. The top number has 2 digits after the decimal point. So the 5 and the 0, so they're both significant because I have a decimal point. Even though this is a trailing 0, is significant. The 0.231, so in this case, there are 3 digits after the decimal point. When I add these two together, my calculator will give me, or if you do by hand, you will get 102.731. However, my final answer is going to be limited by the top number because the top number only has 2 digits after the decimal. The second number has 3. So since this has only 2, my final answer cannot have any more digits after the decimal than the number that has the least. And therefore, I have to cut off right between the 3 and the 1 here. So cut off that 1, and the correct result should be 102.73. Let's look at the multiplication and division rule. This is slightly different because in multiplication and division, we look to the total number of significant digits. So it doesn't matter now if I have a decimal point and numbers in front or behind a decimal. We look to the total number of significant digits. Here's an example. So I have 1.4 and I multiply it by 8.011. This, if you do the calculation, should give you 11.2154. Now I look to the total number of significant digits for each number that I'm multiplying. This number here is only 2. This has 4. 1, 2, 3, 4. Therefore, my answer cannot have any more total numbers of significant, so total significant digits, than the number that has the least, which in this case is 1.4. And therefore, I have way too many here. I have to round to 2 significant digits only, and that is right here, between the 1 and the 2 here. And because the 2 is less than 5, I don't round up, I round down, and the correct result is 11. When we are doing calculations that involve both a measurement and an exact number, the exact numbers do not limit the significant figures of our answer. Let's take a look at this example. So if I have a penny that is minted after 1982, it has a mass of 2.5 grams. Well, what's the mass of 3 such pennies? Well, all I have to do is take 3 and multiply by 2.5 to get 7.5 grams. Note that when if I were to take into account, if this were a measurement, then I would have to round to 1 significant digit. So I would round up to 8. But because this is an exact number, because it's given to me by counting 1, 2, 3 pennies, this will not limit my answer. I do not count exact numbers when I figure out how many significant figures my answer should have. Therefore, the 2.5 gram, which is actually a measured amount from a scale, this is going to limit the answer and the significant digits of my answer. Since this has 2, then my answer should also have 2 significant digits. Let's take a look at some example problems as well, just to get a little more familiar with these calculations and how we figure out significant figures. So let's take a look at the first one, 317.5 plus 0.675. Once again, this is an addition. So when I add or subtract, I look only at the numbers after the decimal point. This one has 1 and this one has 3. My answer can only have 1 digit after the decimal. It can have 50 in front of the decimal. It doesn't matter. I only look to the numbers after the decimal when I'm adding or subtracting. So if I do this calculation, I will add these two numbers together. That will give me, so in my calculator, I'll get 318.175 milliliters. Once again, because this number has only 1 significant digit as compared to 3, my answer should only have 1 significant digit after the decimal. Therefore, I have to cut off between the 1 and a 7, and 7 here. I have to draw that red line as we did at the beginning. And then I'd have to determine whether I round up or down, because 7 is higher than 5, is greater than 5, then I round up. So this becomes 318.2 milliliters. Now, let's take a look at this example over here. I have 13.5 grams divided by 45.18 liters. Note that this is a division, but the rule is the same as multiplication. And now I look to the total number of significant digits. For the top number, I have 3 significant digits. For the bottom number, I have 4 significant digits. If I do this calculation, here's what the calculator will give me, 0.29880471 grams per liter. Because my top number has 3 and has less than the bottom number, this is going to limit my answer, how many digits my answer should have. So since this one has 3, my answer should have 3. I would draw a line between the the last digit that I want to keep and the digit that will be eliminated. So between the 8s here, I would draw a line, 1, 2, 3 digits. And now I look to see whether the digit to the right of that imaginary line, or whether you draw it for real, that doesn't matter. But if I drew the line here, to the right of it, I have an 8, which means that it is larger than 5, and I would have to round up to 0.299. And then everything else here would be cut off. Note that this, if I already had 2.99 here and I were to round up, and it would become 0.300, the fact that you have zeros here instead of 3, those would still count, right? Because I have a decimal point, so I would have 300, and I would still have 3 significant digits for my answer. That's an example for when you have when you're rounding up gives you a 0 somewhere. If you have a decimal point, you still have to count those zeros. Now, I will give you some time to work on these 2 sample problems and determine the proper number of the significant figures after you've done the calculation. Lastly, for this part, we are going to introduce the unit conversions and conversion factors. We are going to be using these extensively throughout the remainder of the semester. And therefore, it is important that you learn them now and that you do enough problems to get enough practice with these conversion factors. A conversion factor is really an equality statement, and I can express it as a fraction. So here's an example of it. I know that 1 inch is equal to 2.54 centimeters. So this is my equality statement. Well, I can express this equality statement as two fractions. So 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. Then I can use these, what I call conversion factors, either form of those, without changing the value of that quantity, but depending on what I'm trying to convert. So if I have centimeters and I'm trying to go to inches, I would use this. But if I had inches and I was converting to centimeters, I would use this form of the fraction. So depending on what I start with and where I want to end up, you'd either use one form or the other of that fraction of the equality statement that we have. Let me show you an example of a unit conversion. Okay, so here's the problem. It tells me, or it asks, how many inches are in 20 centimeters if I know that 1 inch equals 2.54 centimeters. So here's that little box from the previous slide. I have this equality statement, and I have two fractions. So either 1 inch over 2.54 centimeters or 2.54 centimeters over 1 inch. Now, I tell my students, always start with the amount that is given in the problem, not with the conversion factor. This is your conversion factor. Your fractions are the conversion factors. Never start with these. Always start with the amount that the problem gives you, which in this case is 20 centimeters. So let's take a look here. Let's take a look at how would I solve this using both of these fractions, and then how to determine whether I have the right one or not. Okay, I start out with my 20 centimeters. This is the amount that the problem gives me. Then I multiply it by the conversion factor. So if I picked 2.54 centimeters over 1 inch, so if I pick this one, let's see what that gives me. So 20 times 2.54 centimeters gives me 50.8. Now, I have centimeters multiplied by centimeters gives me centimeters squared, and I still have inches at the bottom. So if I picked this conversion factor, I would get 50.8 centimeters squared per inch. But that's not what the problem is asking me. It asks me how many inches there are in 20 centimeters, not centimeters squared and inches. So therefore, this is not the correct fraction to use. Let's try the other one then. I set up the same multiplication, right? So I start with the amount I'm given in the problem, which is 20 centimeters, multiplied by 1 inch over 2.54 centimeters. In this case, because I have centimeters on the top and on the bottom, and I'm multiplying these two numbers, I can cancel the unit here. So centimeters by centimeters will cancel, and what I'm left with is inches at the top. So 20 times 1 gives me 20 inches, divided by 2.54 and gives me 7.874 inches. This is the correct answer in terms of what my unit should be. So I have picked the correct fraction, the correct conversion factor. If I pick this one, you can see my units are not correct. But here my centimeters cancel, and I'm left with the correct unit, inches at the top. The last step is to figure out how many significant digits my answer should have. Since I'm multiplying, but this is now considered an exact number. So any conversion factor is considered an exact number, and therefore these two numbers do not affect the answer. How many significant digits your answer should have. Only the initial measurement. This measurement only has two significant digits. Note that I have a decimal point at the end of this number. That means that this 0 becomes significant. I have two significant digits to this number, and therefore my answer here should have two significant digits. If I draw a line here to 1, 2 significant digits, and I will have to get rid of these two, but because the first digit right after my line is 7, that's larger than 5, I would have to round up, and I do 7.9 inches. When you set these up, get in the habit of always starting with the amount that you are given in the problem, then look to see which fraction does have that unit at the bottom of the fraction. So see, I have centimeters. This is what's given to me in the problem. That means that I have to pick the fraction, the conversion factor that has centimeters at the bottom. That way my centimeters will cancel out, leaving me with the correct unit at the top, which is the unit that I am being asked to convert to. We will be practicing more of these, but your book has plenty of these for you to do, so get some more practice, and then we'll be doing more of these in class.